What's up, y'all? This is part 2 of circles, and in this video we shall be covering the low-key important questions for your board exams. The first question says, I'm supposed to find angle AOC. Always try to understand, step number 0 in your question is to figure out this. Where does this angle lie? This is a simple diagram, so it's so obvious that AOC is lying somewhere here. Again, let's go back to video 1 where we spoke about something called as points of origin. Here, this angle will lead to these 2 points called as A and C, which means in this question A and C are my point of origin. I'll place my fingers there. I'll also try to find out where else are these 2 points trying to form an angle. One is at the center and one more is at the circumference. Here, again, theorem number 1 which we learned in video number 1 or part 1, which said angle subtended at the center is twice the angle subtended at the circumference. In simple language, if I'm able to find this angle, the double of it will be AOC. So my step number 1 will be I'll be trying to find ABC. But the small problem here, you guys realize this, sir? OA and OC in circle has a special name called as radii. So I'll state that here OA equals OC because it is called as radii. So obviously I also realize there's one more point lying on the circumference of the circle, and that point is here, point B. In order to make OB also equal, I'll just extend that line and join O and B. So automatically right now we have 3 radii, OA, OB and OC. Observe properly. Let's go part by part. Don't you think triangle OBC is isosceles in nature? OBC. The property of isosceles triangle tells us what? That the base angles of it are equal, which means if this angle is 40, this part of the angle is also 40 degrees. I'll apply the same concept here. What's the only change? Instead of 40, we have 30 here. So, same isosceles triangle property here. Base angles are equal. So, if this is 30, this also will be equal to 30. This solved a major problem for me, which is, I got to know the complete angle ABC, which was required for me to find the answer AOC. So, ABC is nothing but 30 plus 40, which is nothing but 70 degrees. Based on this, don't you think I'll be able to find the value of AOC? So I'll write AOC will be equal to twice of angle ABC. Based on what theorem? Theorem number 1. The statement is already been told. So my final answer will be 2 times 70, which is nothing but 140 degrees. Obviously, I'm only writing the essential parts of it. You're supposed to explain them step by step. You're supposed to tell OAOC is the radii. Angle OBC equals 40. Isosceles triangle property. Same way, OBA is 30, isosceles triangle property. Then you find the total angle. You're supposed to write step by step. But if I keep writing the steps, the video is going to be too long, and end of the day, you guys won't watch it completely. So that's the reason I'm explaining the most essential parts. Now let's go to the next question. Observe the diagram properly here. Always, step number 0. Figure out what you're supposed to find. Find A. In the diagram, try to locate where the letter A is. I found it. ACB is angle A. Don't you think, again, let's do the work there. Angle A, the origin is A and B. I'll place my fingers at A and B. Also try to understand where else is A and B going towards. One went towards C, one more is going towards D, which means if I'm able to find this angle, ADB will also be equal to ACB. How do I know this? Theorem number 2 in part number 1 video, which said what? Angles in the same segment are equal. I have a small problem here. The problem is, how do I find this angle? I realize that A equals ADC. How do I find this ADB angle? My bad. Now, very simple. Why am I calling it to be very simple? Because BOD is the diameter of the circle. Fine. Theorem number 3 will apply here. BD is subtending an angle towards A, which means theorem number 3 states what? Angle in a semicircle is always right angles. This whole angle becomes 90 degrees. Obviously, you won't be able to understand any of this if you still haven't watched the part 1 of circles. Watch that where I've explained the 5 theorems involving these questions, and then come back to this video. So, this DAB equals 90 degrees. This angle is 35. In a triangle, there are 3 angles. If I give you 2, won't you be able to find the third one? Obviously. How do you find? Sum of angles of a triangle will be equal to 180 degrees. Whatever, so based on triangle ADB, I'll find 90 degree plus 35 degree plus angle ADB equals 180. Based on this, obviously we are going to find angle ADB, which is nothing but 90 plus 35 will give me 125. 180 minus 125 will give me 55. Correct? Now, ADB equals 55 degree. We also know that angle ADB will be equal to A. Based on what? Theorem number 2. I already told the statement, so you will write the statement here. Automatically, the value of A also becomes 55 degrees. So again, step number 1 is the most important thing. You got to place your fingers and try to understand where is the point of origin coming from. So if you're able to figure that out, everything is going to become simple. Let's move to the next question. The next question, this is an interesting question. There are 3 sub-questions being asked, but the reason I use the word interesting here is because if you look at this, unlike the previous questions, there are 4 points which are on the circumference of a circle, and this looks like a quadrilateral. To be more precise, this will be called as a cyclic quadrilateral. I've told the conditions in part 1. I'll repeat that again. If all the 4 points are lying on the circumference and a quadrilateral is being formed like this, it is called as a cyclic quadrilateral. Now, why is it important for us to realize if it's a cyclic quadrilateral or not? If you're done with the finding part of cyclic quadrilateral, I'll be able to apply theorem number 4 or 5 depending on my scenario. Right now, the first sub-question talks about finding the angle BCD. BCD. I'm supposed to find this. Don't you think this is a straightforward question? Because opposite angles of a cyclic quadrilateral are supplementary. Supplementary meaning 180 degrees. Which means if this is 105, this one will be equal to 180 minus 105. Getting as to how it works? So obviously do the math there. 75 degrees. There's one more hint given to us in the same question. Don't you see AB and CD are parallel in nature? Wherever parallel lines are being involved in your circle question, understand, usually alternate angles will be used. If not, allied angles will be used. One of these 2 things has to be used, or else the whole point of marking 2 lines to be parallel will go for a waste. So, next question talks about this. We found ADC. I'll mark ADC first. I'm supposed to find that. Don't you think DC is parallel to AB, which means the diagram looks like this, and AD is the transversal passing there, and this angle is given to us as 105. Can't we find this? Obviously we can find. Again, the meaning of allied will again sum up to 180 degrees. So to find this angle, it will be 180 minus 75 using allied angle property. So this will also be 75 degrees. Okay. The third question, let's look at it. ABC. Before we solve this, I want you guys to smash the subscribe button right now. Do it. I'll find ABC. Now this becomes simpler. Why? ABC, right opposite to it, is what? 75 degrees. We'll apply theorem number 4 again. Cyclic quadrilateral, which says what? Opposite angles of a cyclic quadrilateral are supplementary, which means if this is 75, this 100% will be 105 degrees. That's it. So you gotta get used to the theorems first, which obviously requires you guys to watch the part 1 of the video. Next question. The diagram looks complicated, but let's stick on our basics. In this question, I'm supposed to find COF, this angle, and CEF, both the angles have been marked. One thing you gotta be careful. Here, the center of the circle is O, not E. Okay, center is O, which means wherever the word center is there, also look for any of the points lying on the circumference. They are lying. F is lying, C is lying, as well as D is lying. Fine. So what I'll do, my first question says I'm supposed to find COF. I locate COF, step number 0. Try to see where this angle leads to. It is leading to 2 points called as C and F, which means in this question, the points of origin are C and F. So what do? You place your fingers at C and F, go towards the center. Okay, now then go back to C and F. Also see where else is CF leading towards. It is leading towards point D, which is nothing but CDF equals 32 degrees. Don't you think it's much more simpler for us to find COF? It will be double of it, 64. What's the theorem I'm trying to apply here? I'm trying to apply angle subtended at the center is twice the angle subtended at the circumference. I'm supposed to write that statement. The statement also is required. I'll show the working here. So angle CDF equals 32 degrees and angle COF will be equal to twice of angle CDF. What's the reason? angle separated. I told you right now. You write that reason here. So angle COF will be equal to 64 degrees. Fine. Next, I'm supposed to find angle CEF. I locate the angle here. Step number 0 done. The angle leads to the points of origin C and F. That C and F is hitting E is also hitting 64, which means this angle will also be equal to 64. Now don't get confused between this and this. You might have a question telling, sir, here it was 32, it became 64 here. That's what. This is theorem 1, where center and circumference, both of them are involved. Here I am only involving theorem number 2, which says angles in a same segment are equal. So automatically CEF will also be equal to 64 degrees, but the reason will be different. Here it will be theorem number 2. You are not supposed to write theorem number 2 like this. You are supposed to expand the theorem, which says what angles in the same segment are equal. You get it? Next question. Right now, again, it's a cyclic quadrilateral question. See, wantedly I've placed the questions like this. One circle question, one cyclic quadrilateral question. I'm trying to cover the maximum types here, which has been asked in your board exams. Fine. So first of all, you realize it's a cyclic quadrilateral, but the most important thing here is parallel lines, which means either allied angles or alternate angles has to be used. That's like an unspoken rule. You guys can cross check with all your board exam previous year papers also. Wherever these markings have been done for parallel lines, these two angles will be used. Okay. Now let's start. But the most important thing which is given to us here is RS is the diameter. Diameter meaning semicircle. So I'll finish that first. I'll place the fingers at R and S. It is leading where? It is leading towards M, which means automatically this will be a right angle. What theorem is that? That is theorem number 3, which says angle in a semicircle is 90 degrees. So automatically angle RMS is equal to 90 degrees. You will state that theorem there. Fine. Now obviously look at the triangle RMS. Don't get confused. Both of them are different. It's an angle. It's a triangle. In this triangle, we know two angles. Can't we find the third angle? Obviously it's easy. So it will be 90 plus 21 plus don't know equals 180 degrees. We'll figure it out. 90 plus 29 plus, how do you name this angle? MSR or RSM. Everything is fine. RSM. This will be equal to 180 degrees. You're supposed to state the reason. What's the reason? Sum of angles of a triangle equals 180 degrees. Fine. So this will be 119. Angle RSM equals 61 degrees. Correct? Now, which means RSM is found, but this is 61. If you focus here, this was not asked in my question, but still it is essential for me. Now, finding RNM. Where is RNM? This triangle. Okay, that triangle I'm supposed to find. That triangle I'm supposed to find. Cyclic quadrilateral. If this is 61 degree, that will be 180 minus 61. What theorem? Opposite angles of a cyclic quadrilateral are supplementary. So that angle I'm talking about RNM will be equal to 180 minus 61, which is nothing but 119. I'll mark this. Correct? Now I'm supposed to find NRM. I'll mark that carefully. NRM is this double angle here which I have marked. Fine. Now don't you think, okay, I'm supposed to find this. This unknown belongs to triangle RNM, the smaller triangle again. In a triangle, if two angles are given, I can have the third angle, but there's a slight problem here. Two angles are not given to us. So how do I do? Just now I told you, no, this line and this line are parallel to each other. Imagine this to be the transversal. So that Z is being found there. Wherever that Z letter is being found, automatically we apply alternate angles property. So if this is 29 degree, this also becomes 29 degrees. Getting it? So you will write that, angle NMR is equal to MRS. This angle and this angle are equal based on alternate angle. You're supposed to write it. I have no space, but you should write it. Now, in triangle RNM, two angles are given. Can you find the third angle? Automatically. How? 119 plus 129 plus unknown equals 180 degrees. You'll get the answer. So after calculation, you'll get this answer as NRM to be 32 degrees. What's the reason you guys will give? Sum of angles of a triangle equals 180 degrees. The next question, guys. I'm supposed to find what? RQS, I've marked here. RTS is this. Okay, fine. Now don't you think, okay, look at this. This angle is given to me, 42 is given to me. So what do? I place my finger at the angle and I try to find the points of origin. It is S as well as R. I'll place the fingers there. One is going towards the center, which is 42. One more is going towards the circumference. Center circumference, which means theorem number 1, and this becomes half, 21 degrees. What theorem? Theorem number 1, which says angle subtended at the center is twice the angle subtended at the circumference. Done. Okay. Now one more thing. What is given to us? PQ is the diameter. Wherever the word diameter is given, usually theorem number 3, which states angle in a semicircle is right angles. That property can be used. So PQ is the diameter. Place fingers at PQ. See as to where it is going towards. It is going towards 2 points. One is, it is going towards R. One more is going towards T. Don't get confused. T will not be considered because that is somewhere outside the circle. Only R will be considered. So from PQ, go towards R, which means this complete angle will be equal to 90 degrees. It is important for you guys to write that. You should tell PRQ equals 90 degrees, open bracket. You should write angle in a semicircle equals 90 degrees. Fine. Now, out of 2 questions, one question we found which is nothing but RQS. I am supposed to find RTS. Let's apply a regular property of a triangle. Heard of something called as exterior angle property, where we learnt exterior angle equals sum of interior opposite angles. Now just imagine, this is 90, exterior angle. For which triangle? For triangle RQT. Correct. So don't you think 90 will be equal to 21 plus RT, or 21 plus RTQ? I'll apply that. So I'm telling 90 degrees equals 21 degree plus RTQ. What's the reason? Exterior angle equals sum of interior opposite angles. This is for a triangle. So this was a triangle what I was dealing with. So obviously next step will be RTQ will be equal to 90 minus 21 degrees, 69 degrees. That's it. See you in the next video.